Hey everyone, welcome. Today is practice quiz. Today we're going to go over practice quiz 5.1 to 5.5. Okay, let's start. First, you have to read the question. It says, tell whether the ordered pair is a solution to the system of equations. This is the system of equations, and show all work to show that. Okay, so the first thing I always do is make sure I underline what the question's asking. So it says, tell whether the ordered pair. So we want to know whether the ordered pair is a solution. And then we need to show all work, okay? So show that, how do we show that the ordered pair is a solution? So to do that, we plug in the x value and the y value of the ordered pair. So this is our ordered pair, negative 3, 5. We plug negative 3 where x is, and we plug 5 in for where y is, and we do the same thing down here. Negative 3 goes there, and 5 goes there. And if the number turns out on this side to equal 8, then we say yes. If it turns out to be negative 69 here, when we plug in the x, y, then if both of these are true, then it is an ordered pair solution. Okay, so let's begin. Let's do the first one. Let's say 9 times negative 3, okay, plus 7 times 5. And then we get negative 27 plus 35. And 20, 30, 40, 50, 60. Okay, oh sorry, it's so negative 27 plus 35, you subtract, and 35 is larger, so that means it's positive 8, so it turns out to be 35 minus 27, it's positive 8. And that is true because this side right here, this side, when we work it out, it's 8, so we can cross this out and put 8 there, 8 equals 8, that's true. So we say check, check, okay? And then let's try the bottom one. We say 8 times negative 3 minus 9 times 5. And we want to see if this side equals negative 69. So let's find out. 8 times negative 3 is negative 24 minus 9 times 5 is 45. So we get negative 40, 40, 50, 60. Plus 5 and 4 is 9, so that's going to give us 69. You add, when it's both minus and negative, you add them together and you give them the sign, which is negative 69. Hopefully you know your signs. Sign addition. So that's true and that's true. So it works for both of those. So yes, the ordered pair works for that. So we say yes. And then for this next one here, we're going to do this first. Okay. So we're going to get negative 8 plus 5. We're going to make sure it equals a negative 3. And we sure do get negative 3. Okay, so that's check. Okay. And then we want to, so we're going to do the next one, which is 3 times y. This is our y and that's our x. So it's 5 times 5 equals 2 times negative 8. And then minus 16. Okay, so we get 15, and we want the other side to be 15 too. So we want this side to be 15 in order for that pair solution to be true. So let's see. What do we get? Negative 16 minus 16. We get negative 32, and that does not equal. So see, this does not equal. 15 does not equal negative 32, so no. Even if this top one works, this one works out, negative 3 and negative 3, but the bottom one doesn't work out. We have negative 32 and 15, so that's no. Okay? All right, so this next question, question 3, we have solve each system equation by graphing show all work. So we have to graph. We have to solve it by graphing, and then we have to show our work. Okay, so let's graph. So one of the things we can do quickly to graph this is what we called a y-intercept and x-intercept. So let's find that. Let's do that. We're going to work it here. So let's look for the x-intercept. What's the x-int? Okay, so to do that, we plug in 0. We put in y equal to 0. So I'm going to plug in 0 in for the top one, for y there. So let's do that. So we say x minus 0 equals 1. So x minus 0 is, x equals 1. So our x-intercept for that first one right here is at 1, 0. And then we're going to do our y-intercept. Okay, what is it? So to do the y-intercept, we set x equal to 0. So we're going to set for that equation for x minus 1. So here we're doing x minus 1, or x minus y equals 1 here. This is the equation we're doing right now. Okay, so we plug in 0 for x, so we get 0 minus y equals 1. And so we get negative y equals 1. So here's the important thing. You cannot have a negative when you have to get y by itself without the negative. So that means you have to multiply everything by negative 1. Means you're going to get y is equal to negative 1. So the y-intercept here, then it is 0, negative 1. Okay, so now we have our 2 points. So let's graph that. 1, 0 is our first one. So 1, 0. And then our next one is 0, negative 1. So 0, negative 1 right here. Okay, and so let's draw a line here. Where's our line? Should be a line. So what we want to do is we want to make sure you draw a nice straight line. Okay, so in order to draw a nice straight line, we need a ruler. So we're going to use the ruler here. And perfect. So we're going to just draw a straight line like that. Okay. And let's get rid of the ruler. Okay, so there is our 1. So let's graph the other one. We have x, y, so let's use a different color for that one. That one is x plus y equals negative 5. So our intercept is at, we have to set y equal to 0. Okay, so that means x plus 0 equals negative 5. So we get x is equal to negative 5. So that first point is negative 5, 0. Remember our y is 0, that's why that's 0. And then let's do the y-intercept. And what's the y-intercept? We have to set x equal to 0. Then we have 0 plus y is equal to negative 5. And so we have y is equal to negative 5. So we have 0, negative 5. Okay, so here's our 2 points we're going to use to graph. So we have 0, negative 5. Where's our 0? 0, 1, 2, 3, 4, 5. Okay, and then we have negative 5, 0. 1, 2, 3, 4, 5. Okay, using our ruler, there's our ruler. Let's move the ruler around. And we have, just make sure it's nice and straight there. Okay, but right there. The reason you have to do it really straight is because then if you don't do it correctly, then it won't be right. Does that make sense? The connection won't show correctly, right? So there it is. And so our intercept is in this particular location. Right here is our solution right there. Okay, so our solution would be, if we count it out, we go 1, 2, 3. So -3. Let's use red. Yes. We got -3, and we go down 1, 2, 3. Looks like -1, 2. Sorry, that's -2. -3. Okay, so we go 1, 2. It's -2. Then you're gonna go down. So 1, -2, -1, -2. You go down 1, 2, 3. So -2, 3 is our solution. Okay, and then you might ask why is this y equals 0 for those of you who forgot. And why do we to get the x-intercept? Because if you think about it, the x-intercept is on this line right here. Okay, so anything that crosses that line we call the x-intercept. If I draw a line straight here, it crosses right here. And the x-intercept is always some number and the y is always 0. That's why we set y equal to 0. If it crosses the y-intercept, let's say at this point, the x value is always 0. Then the y value is some number. That's why we set, for the y-intercept, we set x equal to 0. And that's the reason why. All right, what if you're not sure if this is the answer? Plug it back in, check to see. You got -2, -3, so -2 minus a -3, that's going to be a +3. So -2 plus 3 is 1. That's true. How about -2 plus -3? That's -5. That's true too. So yes, this is true. All right, that's how you check it to make sure. All right. Question 4. So another way to graph is to also set the equation in slope-intercept form. So as you can see, this is already in slope-intercept form. This is the slope, -3, and this is the y-intercept 2, but this is not in the same way. So we can solve for y, get y by itself. So let's do that. Let's make blue, I guess. Yeah, let's just stick with red. All right, so subtract 2x from both sides. When we do that, we get negative y is equal to minus 2x and plus 3. Okay, equals. So we can't have that negative y there, so multiply everything by -1. So that has to be multiplied by -1. So when we multiply the whole thing by -1, we're going to get y is equal to 2x plus -3. I apologize. It should be -3 because you're multiplying by -1. So you're going to get -3. Okay, so now we're ready to graph. So -3, we start at -3. So we go 1, 2, 3. That -3 is our y-intercept. And then our slope is 2 over 1, rise over run. So it's 2 over 1. You have to imagine that. So we're going to go 1, 2 over 1. Positive is up, to the right is up, or to the right it's positive. If you go down, it's negative, and to the left it's negative. So we're going to go up 2 from where the y-intercept is, -3. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Okay? That's enough. All we need is 2 points. But if you go down, 1, 2, 1. Down is negative. To the left is negative. Negative over negative is positive. Okay? 1, 2, 1, like that, right? And then let's do the other one. The other one is set for us already. The y-intercept is 2, so we start at 2 here, and our slope is -3/1. Okay, so now it's -3. So that negative could go to the 3 or to the 1. It doesn't matter. So let's use it to 3. We go down 3, 1, 2, 3, then over 1. Okay, and then down 3, 1, 2, 3, over 1. Okay, and down 3, 1, 2, 3, over 1. Okay, so here we can go up 3, 1, 2, 3, but that whole thing has to be negative, so we have to go to the left, -1. Okay, like so, 1, 2, 3, over 1. Okay, and then we can use our ruler. Let's use the ruler here. Let's draw the blue one first, since we have the blue one already. And we know where the intersect is. We don't have to graph it, but just graphing it for the sake of graphing, because it says to graph it, right? So let's do that. And again, we could do the last point and that point right there. Okay. And the ruler part is the tough part here. Gotta get so exact. I don't like solving by graphing. This is the main reason why I don't like graphing, solving by graphing, because you have to be exactly on the ruler, or else you can't get the correct where it's supposed to intersect. And when you graph, you always want to go beyond the point there, like that. Okay, and then let's do the red one. Let's go the other way, and you can already see, but we're just going to finish it out here, and then making sure that's correct there. Not a fan of this ruler thing. Not a fan at all. Okay. All right. Jeez. Okay. Just do that right there. All right. So there we go. Whew. That just seems crazy. And our answer then is, we can see where the intersect is. It's right here. And it's at 1, -1. So our solution then would be 1, -1. And so how do we know? We can plug it back in. 1 is 2, -1 is 1, 2 plus 1 is 3. Okay, and then the bottom one, -3. 1 times -3 is -3. -3 plus 2 is -1, and then y is -1. Yes, that's true. So yes, that is correct. So for this one, for number 5, okay, for question 5, I think you can do the y and the x-intercept, but the reason I want to choose the put it in slope-intercept form to graph is because you can see if they have the same slope, you know that they're going to be parallel, or whether they have infinite solution if they're exactly the same equation. So, and it's much easier to graph with slope-intercept form. So let's set it equal to y, so y-intercept form. So let's do the first one here, x. So we have, let's make the first one red. So the first is x plus 2y, 4. So we're trying to get y by itself, so subtract x. Both sides, this becomes 0 on the left, so you're going to get 2y equals. The reason we like to have x here first, instead of saying 4 minus x, we can say negative x plus 4. And you see why, because 4 is positive, so it's plus, and negative x is actually minus. You can use as negative. So if you say 4 minus x, we're not used to having x on that other side, so it's better to have the negative x there. And then to finish it off, we divide by 2, and you don't, and the trick here is you have to understand it's by everything on that side. Divide by 2, not just the x, but the 4 as well. So here, then we're going to get y is equal to, that's a negative 1 is assumed in front of x. So just to make it clear, it's negative 1/2 x plus 2. Okay. Then let's go to the blue. The next one is, so we did our this first one here. So our second one is in blue. 2x plus y equals negative 1. We want to get y by itself. This becomes 0. Okay, so it's just going to be y is equal to negative 2x minus 1. Right, so now we're ready to graph. Let's do the red one first. So the red one is here. Our y-intercept is 2, so 1, 2. And then our slope is negative 1 over 2, so go down 1 over 2, down 1 over 2, down 1 over 2. And you can go the other way too as well. You can say up 2 or up 1 to the left 2. It's still a negative number. It's negative 1/2 basically. So that negative can go to the 2 or to the 1. So we have that. And then, so let's graph the blue one. So we have negative 1 is our y-intercept. We start there. See, negative 1 is the y-intercept. Negative 2 is the y-intercept up there. So negative 1. And remember, there is a 1 beneath here. So it's negative 2 over 1. So we're going to go down 2, 1, 2, and over 1. Okay? 1, 2 over 1. 1, 2 over 1. And we can also go 2 up. 1, 2 over 1. Okay? 1, 2 over 1. And we see where they connect right there. But let's just graph it anyways. Let's graph that with our handy dandy ruler here. Let's graph the blue one since we did the blue one first. Okay, about right there. Right there. Nice. Okay, and then we do the red one. Oops, what happened there? Okay, let's try again. Red one, okay, we must have hit that button there. Okay, let's make sure. I'm not a fan of graphing to solve. I like to actually solve it with math. Okay, and we see that the point is actually right there where it intersects. And so when you do the test, what's important here is make sure you're accurate with make sure you're accurate with how you're graphing it. So it intersects right here. So our solution then, we can just do that in red. No, actually, let's do it in, gosh, I hate to use another color. Let's see if it can give us another color. Here we go. Let's do it in, not a lot of choice in terms of colors. Let's do it in blue. That's the answer. Okay. So our answer is, we have 1, 2, negative 2, 1, 2, 3. Let's see. 1, 2, 1, 2, 3, negative 2, 3. So again, if we're not completely confident with our answer, -2, 3, we plug it back in to check. Okay, if you're like, I'm not really sure that's correct, plug the -2, 3 in and check to see. Okay? All right, now for question 6. Now we have inequalities. So graphing inequality is pretty much the same except that there's more solution and you have to do shading. Okay, so let's graph that. So we have our y-intercept is -2 and our slope right here is -3/1. Remember, there's always a 1, assumed a 1. So let's start -2 and we're going to go down 3, 1, 2, 3/1. Remember, down is negative, to the left is negative, okay? And we can also go up 3, 1, 2, 3, that's positive, but that number has to be a negative, so over 1, -1, okay? So that makes 3 negative. We do the same thing again, 1, 2, 3/1, okay? And then, so what we need to notice is that when you have that greater than, the line that we're going to draw is a dash line. It's got to be a dash line, okay, to connect the dots. That tells us that the answer cannot be on that line. If we have an equals, like greater than or equal, it's a solid line. That means any point on that line works for the solution. Y is greater than -3x minus 2. So only, so the dot lines represent any point on that dot line will not work. Okay, so let's graph it. All right, let's get our handy dandy ruler out and graph that. Remember, I have to use dash lines. Okay. See, 3. Okay. See if I can do dash. Do justice on it. Dash. All right. All right. Let's say dash. Okay. Perfect. Awesome. There's my dash line. And so the next thing we need to ask is which side do we shade it on? So we always pick point 0, 0 because it's the easiest to test. So what we do is we pick 0 for x and 0 for y. So we plug that in. 0 greater than -3 times 0 for x minus 2, 0. What's -3 times 0? 0. And then we have minus 2 is 0 greater than -2. And our answer should be yes, 0 is greater than -2. And so that means, see the point 0, 0 here? It's right here. So if 0, 0 is on that side, that means any point you pick here on this side is an answer. Can you pick any point on the dash line? No, none of the points on the dash line will work. Okay, so this is an example, like this point right here will not work. That point will not work because it's on the dash line. Okay, that's very key to understand. Okay, so that's it. All right, now for question 7, you're still graphing and that looks really complicated, right? But in fact, let's make it nicer. And so to do that, we have to reduce it. So we can do the 2x minus, we're going to multiply 3y, and then -3 times, so -3 times y is -3y, -3 times 1 is -3. Okay, that's greater than y minus 4 plus x. That still looks horrendously horrible. So we wanted to put it in, we want to get y by itself so we can get it in slope intercept form. Okay, so what we do then is we want to move the x to the right and the y to the left. So let's subtract 2x from both sides. And notice when I'm subtracting, I don't have to do it to every single thing. I can do it to any term that's the same. I don't have to subtract 2 from y or from 4 that I can just only do to the x. But when you're dividing and multiplying, you have to do to everything. Okay, so that's very key to understand. So this is gone. So now I have 3y minus 3 is greater than or equal to y minus 4. That's going to, x minus 2x is going to be x like that. And then add 3 to both sides. Okay, and this is 3 minus 3 is 0. So now you're going to get 3y is greater than or equal to y. And that's going to be minus 4, negative 4 plus 3 is minus 1 minus x. Still does not look great. We need to get the y by itself. Track y from both sides. And we're going to get negative 4y is going to be 0. And we're going to get, I'm just moving the x to this side. You can do that. That's legal. And just do that. Okay. Because I want the x right there. Okay. And then the y is almost by itself. So the last thing we need to do is divide by negative 4. Okay. Notice I divide by negative 4, not just 4, because we can't have the negative left over. So I have to do here. Negative 4 here, and also divide by negative 4 here. So then I'm going to get y is greater than or equal to, negative over a negative is positive, so there's a 1 there. There's 1/4 x. Remember, there's a 1 in front of x. There's always a 1 in front of any variable, okay? Then negative 1 over negative 4 is plus 1/4, okay? And that is our scary little thing there. This is our final inequality, and I'm not going to give you anything like this on a test because fractions are very difficult to graph. We just have to estimate. So our y-intercept is a quarter. Quarter is half, so it's maybe right there somewhere. A quarter, and then our rise is 1. So that's going to be 1 rise over run is 4. So that's going to be 1, 2, 3, 4, something like that. And it's going to be, I'll just freehand draw this one because it's inaccurate already, something like that. Okay. And then we pick, that's slightly above 0, 0, right? 1/4. So we plug 0, 0 in there, see if it works out. So we plug in to see what side we shade. 0 is greater than, is that 0, 1/4? Is 0 greater than or equal to 1/4? 0 is not greater than or equal to 1/4, so remember 0, 0 is on the bottom because I drew that line a little too big, but 1/4 is a little bit higher and 0, 0 is right below it. So all the points here won't work below here. So 0 is on that side, so that means any point on this side won't work. That means the top points will work. Okay, any points located up there will work. All right. For this question, which order pair is the solution of the system? So the tricky part is actually you just need to find they all have to work. So any of these points that you plug in to this system, they all have to work. So what I would do is I would plug in these first, the x and y. Check these first before you check this. If one of these doesn't work, then just go on to the next one. Let's do that. 3/2 for x. Is that true? Is 3/2 greater than 0? Yes. How about y? 0. Is 0 greater than or equal to 0? Yes. Okay. How about here? So this has to work too. Is 4, so y is 0 here. Is 4 times 3/2, 4 times 3/2, 4 times 3 is 12. 12 divided by 2 is 6. 6 is 6 greater than 8? No. So A doesn't work because of this. These two work, but this one will not work. Let's go to B. 5 is greater than 0. Yep, is -1. greater than 0 or equal? Nope, it's not greater than, so it doesn't work. So C, 0, 0. Is 0 greater than 0? Yes. Is 0 equal to 0? Yes. Is 0 greater than or equal to 0? Yes, because 0 is equal to 0. So now we got to check this one. I put 0 in here, I put 0 there. Is 0 greater than 8? No, so 0 is not the answer because this one didn't work right here. I'm going to go to A, B, C, D, negative half. Is negative half greater than 0? No, that doesn't work, right? So that means that this doesn't work. If one of them doesn't work, the whole thing doesn't work, okay? 7, 3. Is 7 greater than 0? Yes. Is 3, because 3 is y, is 3 greater than 0? Yes. How about this one? So 7 is x, 4 times 7 is 28. 28 minus 3 is 25. Is 25 greater than 8? Yes. So E is your answer. E is your answer, folks. E. Now we're going to graph the system. So we're going to graph it, and this is nice. Number 9 is already in y-intercept form. So let's do that. So we have negative 3 is our y-intercept. 1, 2, 3. Oops, sorry about that. Forgot to hit that. So negative 3, 1, 2, 3. And then our slope is 1, 1. It's 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. And it's equals, so that means it's a solid line. Let's do the next one. We have 2 is our y-intercept, 2 here. And our slope is negative 1 over 1 or 1 over negative 1. Either way, so I'll show you the negative 1 over 1 first. So negative 1 over 1, negative 1 over 1, negative 1 over 1, okay? So fourth, and we can go 1, 1, 1, 1. Remember, to the left is negative, so, and 1, 1, 1, 1, okay? Graph the system inequality, show all your work. Okay, so that's what we're doing, graphing it. So we're going to get, where's our nice handy dandy ruler? All right, let's do, I think, red. And it's solid line, remember it's a solid line because it's solid line because it's equal to, then we do the blue, and the blue is here. It's also a solid line, so we go, oh, what happened? Uh-oh. Oh, now it's working. Okay. Oh, I hit the eraser. Dang it. There we go. Back. Ay. Ay. Oh, that's chaos. All right. Let's try again. Here. Okay. Here we go. Work. All right. Let's do some shading. Ruler out. Okay. So we check. Let's check the blue one first. Where should we shade? So if I put 0, 0 in for the blue one, the blue one is the top one. Y is greater than or equal to x minus 3. So I put 0, 0 in. I'm going to get negative 3. Is 0 greater than or equal to negative 3? Yes, 0 is greater than negative 3. So that means the 0 on this side works. So that means I need to shade this blue part like so. Okay. And then the red one, 0, 0. does that mean that's going to work? So is 2 greater than 0? Yes, it is. So that means the red one, the bottom part is going to work because 0, 0 works for that. Because 2 is greater than 0. That means I need to shade this part red. Okay, so it means if they ask for a solution, that means this is the only pair that would work for this. So you pick any point inside here. Any point you want to choose as long as it's in here. And even on the line too. On these lines, the points work. That's very important to understand that the points on these lines will work too because it's solid. Okay, so let's go to 10. 10. Ooh, yeah, 3 things to graph. Okay, so x is less than 3. So here's our x value, 1, 2, 3. So that means we're going to have a dot here, like so. This is x less than 3. Okay, and then the next one, let's do make that a green. Okay, let's do red. Or we just did red. Let's do blue. Y is greater than 1. Here's when y is 1. And this is also a dotted line. Okay, and then the last one we're going to have to use green. Y is greater than or equal to -1. So this is actually tricky. Our y-intercept is 0, and our slope is -1 over 1. Okay, x, like that. That's a tricky one. Okay, so we start 0, and we're going to go down 1 over 1. So here's 0, down 1 over 1, down 1 over 1, down 1 over 1, up 1 over 1. Okay, still negative, so that negative number can be on the bottom. It could be 1 over -1. So this is what we get, and we get a solid line for this one. Freehand. Okay, so we have to shade still. X is less than 3. So if I choose, so this is our red color, and this is our blue color, and the last one is our green color. Okay, so the red x is less than 3, so that means all the numbers we choose needs to be less than 3. It doesn't matter at any point, but we can, oops, turn it red, this, okay, down the line here, less than 3, and then for the blue is y is greater than 1. So the blue is greater than 1, so we shade up here like this. Okay, and then the last one's green. Y is greater than or equal to -x. So we plug in 0, 0 there. Is it's going to be a straight line there. It's right on. We can't. Okay, so here's the issue. If you plug in 0, 0 is right on the line. So we need to plug a point that's not on the line. So because 0, 0 is right there, you see it right in that center there. We can't use 0, 0. So let's plug a better one. Let's say 1, 1 right here. Plug 1, 1 in. If it's true on that side, we shade that side. Okay. If it's true, if it's not true, then we shade this side. Okay. So let's plug in 1, 1. So we're going to get 1 is greater than or equal to. That's a negative, because negative is on the outside of x, and 1. So it's going to be is 1 greater than -1? Yes. So that means we need to shade this side. Okay. So where are all the points that work? And it looks like it's in this location right here. These point right here, that will work. Hey, finally we're on the last question. Okay, so a couple things you need to notice as you read, underline the important things that you see. During the summer, you want to earn at least. So here's the word at least. That means that you should make 120 at least. But you can make more. So at least means that it needs to be greater than or equal to 120. And then you earn $9 per hour for babysitting, and you earn $6 per hour working at a grocery store. And then you can work at most 25 hours per week. So here's the word at most. So that means you can't go beyond that, but you can have 25, but you can't work more than 25 hours. Maybe because for legal reasons, or you need more of those hours to study for school. So you shouldn't work more than 20 hours per week. Um, all right, so let's get started. So write a system of inequality to represent the situation. Let X be the number of hours per week babysitting and Y be the number of hours per week working at the grocery store. So make sure you use those letters to represent them. So X is the number of hours babysitting, and Y is the number of hours working at the grocery store. Okay, so remember that. So we'll just write it down so we know. X hours babysitting and Y is hours work at grocery store. Okay, so now you have that down. So we need to write a system of inequality. Okay, so it should make sense to you that if you multiply the number of hours worked babysitting plus the number of hours worked at the grocery store should give you a value of greater than 120 or equal to 120. Okay, that's what you want. So we have the babysitting is $9. Actually, I'm going to use red for that one. So babysitting $9 an hour plus the $6 an hour for groceries. Okay, and that has to be greater than or equal to 120. And then X plus Y, which is the number of hours worked for babysitting and the number of hours worked at the grocery store. That needs to be less than, now this could be actual things in real life that you actually have to calculate if you're working at two different places and you're trying to earn money and save money up for college. So this is it. This is the inequality. That's the biggest thing you need to get is getting the equation correct. So when you're graphing it, number 12, the graph the system of inequality, the hard part is maybe you're not used to how do you get the units correct. You see the unit here, you have less than 25, I got to 24, so what's the increment you use? So the best way to do that is count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. There's 12 increments here. If you take 25 divided by 12, you would get a decimal point basically. 25 divided by 12. It tells you how much you do. It's 2. It's 2.08 for each increment. So instead of just saying 2.08, I round it up to 2. So every increment is 2, so that's 2, 4, 6, 8, okay? And so for this one, you have 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So 12 120, so you take 120 divided by 12, and it says to use 10, so that's what I did. 10, 20, 30, 40, 50, 60. And that's the best way to do these types of things. And you're going to use this in next year too in physics. So remember that. Take the number of these individual lines and then use that divided by what you have. All right, now it's time to graph. Like we can put it in y-intercept form. Let's do that. Let's say, let's do the first one. We just use the red. Okay, so I'm going to take 9x plus 6y is greater than 120. Remember, we're solving for y, subtract 9x from both sides. We get 6y is greater than or equal to negative, or sorry, yeah, negative 9x. I need to make that clear. Negative 9x plus 120 divided by 6. And then we're going to get y is greater than or equal to 3 goes into both of that. 3 times 2 is 6x. And then 6 into, that's 20. Okay. Because 6 times 0 is 0. 6 times 2 is 12, so 120. Okay. Because 20 times 5 is 100, and 1 more is 120. So here's our first one. Then let's do the second one. Let's use blue for that one. And it's x plus y is less than 25. So subtract x from both sides. We're going to get y is less than or equal to negative x plus 25. Okay, and so let's graph that one first. So our y-intercept is 25. Here's 20, and here's 20. That's 30, so 25 is about right here. And then our slope is negative 1, 1. Okay, so that's tough. Okay, so here's the issue we run into, is that you can't use the y-intercept because of this, for this fact, because our points are too small. So we have to completely erase that idea, okay, because our increments are too small. It's way too hard to estimate where 1, 1 is. So this is the reason why we have to use the x and y intercept. Okay, so that means we can't use this. I know all that work for that, right? All right, so we're going to use the intercept. So let's do the red one first. So we're going to ask, when x is 0, what is y? So we made 9 times 0 is 0. And so we have 6y is greater than or equal to 120. Divide that 6 by, and you're going to get y is greater than or equal to, remember we said there 20, right? So y is 20. So that means our intercept for this one, we did x is 0 and 20. So this is our intercept. So we're doing this one first right here. Okay. And then we have to say when y is 0, what is our x value? So that's going to be, so that's going to be 9x is greater than or equal to 120. Because remember, we're asking it when y is 0. So we plug 0 in there, in here. Okay, that's going to be 0, and you should leave us with 9x is greater than or equal to 120. So divide by 9, and we're going to x is greater than or equal to 9 to 12 is 1, 20, so that's going to be a decimal point. So let's use 3. Let's see if 3 reduce 3. 120 divided by 3 is 40. 40 over 3, let's just make it a decimal point. 120 divided by 9 is 13.33. So x is greater than or equal to 13.33. Okay, so that means the x-intercept is 13.33, or we can say 0. Okay, so this here is for this one right here. Okay, so now we're going to do the bottom one. The bottom one's easier because there's no numbers in front of x or y. So we're going to look at x first. So if we, or y first actually. So if we plug in 0 for x for the bottom one, we're going to get y is equal to 25. So our intercept's going to be 0, 25, and then when we plug x into, when we plug 0 into y, x is going to be less than or equal to 25. Okay, so we get 25, 0. So here's our 2 points we can use. Okay, so let's do these one first. Let's plot this one here and this one here first. So 0, 20. I'll use blue. Red, we'll do red for that one. So it's 0, 20. Okay, where's 0, 20? 0, 20. And then 13, 0. So 8, 12, 12, and this is 13 right here. So about right here. Okay, so our first line is going to be about like that, somewhere like that. Okay, because it's greater than or equal to, so it's a solid line. And then our next one, we're going to do this one next, these 2 points here. Okay, so it's 0, 25, 0, 25, this is 30, so 25 would be right here. Okay, and then 25 is 0, so 25, 0, 24, 25 would be, so the line, ooh, we have an issue here. Right there. All right, so now we have our graph set up. So now we just need to shade it in. So let's look at the first one. So we're looking at this one right here. This line right here is 0, 20 and 13, 20. So it's this one. Okay, so we're looking at the red line. If we plug in 0, 0, this would be 0 on this side. Is 0 greater than or equal to 120? That's false. So nothing is correct up here, so we have to shade on the top part. So it doesn't work anything below, so the red part gets shaded up here. Oops, should be red. Let's do red here. So red, 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 red gets shaded. Okay. And so forth. All red right here. And then look at the bottom part. The next one is this one, the blue one. So these two numbers are the blue one right here. So we plug 0, 0 in here, 0, 0, less than is 0, 0 less than 25 false. So got the blue one, all the lines that work for the blue ones on top. Okay, so this one, these one will work on top here. Okay, so nothing below this point will work. Nothing will work here. Everything above here, so it's in between these points right here. Okay, actually both are covered, so it's all these points. Anything here, the whole thing right there will work. Right. Okay, for the last question, 13, it says you are scheduled to work 12 hours per week babysitting. What is the range of hours you can work at the grocery store to earn at least 120 per week? So that means that you need to use this second equation, this one right here, because it is, you're looking at this 120 per week. So it has to, whatever hour you use has to be greater than 120 or equal to. So you have to plug in 12 hours for babysitting in here and then solve for y. Okay, let's do that. So we get 9 times 12 plus 6y greater than 120. 9 times 12, 9 times 8, 9 times 2 is 18. So bring with this 108 plus 6y is greater than 120. Subtract 108. We get 6y is greater than or equal to 12. Then divide by 6, and we get to y is greater than or equal to 2. So that means, okay, so that means y is greater than or equal to 2. That means that you can work any hours 2 or more. So anything equal to 2 or greater than 2 will work, and you'll get 120 or more dollars for that week. All right, that is it. I will see you next time.